The laws of electrodynamics prevent an electron from orbiting the nucleus. Therefore, a new approach was needed to explain the structure of the atom. Atomic spectra continued to be a puzzling phenomenon. When atoms are energized, they emit light at specific wavelengths. Atomic spectrum contains only specific lines, rather than continuous spectrum like a rainbow. Each element from the periodic table has its own barcode. Physicists were unable to unravel the source of the spectra. Swedish scientist Johannes Rydberg formulated an empirical equation that unified the lines of the hydrogen atomic spectrum into a single mathematical expression. In this equation, RH stands for the Rydberg constant for hydrogen. However, the origin of the spectrum's structure remained a mystery. In 1913, Danish scientist Niels Bohr introduced his atomic model. He presented it in the form of three postulated statements, a starting point for further discussion. The first Bohr postulate states that electrons orbit the nucleus in stable circular orbits without losing energy. This postulate conflicts with the principles of electrodynamics. However, Bohr's second postulate aimed to demonstrate that certain orbits deviate from the rules of electrodynamics. It states that specific orbits exist when the angular momentum of an electron circling the nucleus is equal to an integer multiple of the reduced Planck's constant. The radius of these orbits can be calculated by multiplying n by the reduced Planck's constant and then dividing the result by the mass and velocity of the electron. At n equals 1, the radius of the first orbit is obtained. At n equals 2, the radius of the second, and so on. The third Bohr's postulate states that electrons can transition from one orbit to another by releasing or absorbing a specific amount of energy, equal to the energy difference between the two energy levels. To transition from orbit 1 to orbit 2, an electron needs to absorb energy equivalent to the energy gap between these two levels. If an electron transitions from a higher to a lower energy level, the same principle applies, with the electron releasing energy in the form of a photon. Since the energy and wavelengths of emitted photons are strictly determined, Bohr concluded that they are responsible for the atomic line spectra. He developed a formula for the wave number of spectral lines based on quantized angular momentum and radiation energy. K is a constant derived from the mass of an electron and the Coulomb constant. This formula closely resembles the Rydberg expression for the wave numbers of spectral lines. The Bohr model of the atom elucidated spectral lines and theoretically determined the Rydberg constant. However, there was no further experimental evidence to support the accuracy of Bohr's atomic model until the Frank-Hertz experiment.